you're required to make large deals, sometimes north of millions of dollars. I started programming in third grade, so I think like whatever that is, right? I called them out on it, and they blocked me from their Telegram. A trillion with a T, right?
Hey, Greg.
Hey, Julius, how are you?
Good. How are you?
I can't complain. Beautiful day in Austin.
So, we're meeting today to get some updates on Akash, and I have some questions here for you. And I would love to chat about that stuff. But I mean, for people that don't know you, they might know you because you're taking some awesome pictures with your Leica at conferences, right?
Yes, I'm a photographer.
How did that come? Like, why are you doing that?
Why do I do it? Why do I do it is when you're an entrepreneur, generally, you always have the side hobbies before being an entrepreneur, right? For me, Akash, the company behind Akash, was my side project, Overclock Labs. And when your side projects become your full-time jobs, you don't have your hobbies anymore. And it's healthy to have a hobby. So I've tried several hobbies and nothing really stuck with me. And photography did, for the reason because I'm a cartoonist. So I like to draw things. Cartooning I like because it is caricature in portraiture, right? So you draw a portrait, but you also put the character. You can communicate quite a lot. And cartooning was really fulfilling, but it was very time consuming. Mm-hmm. So I started doing black and white analog photography on film, on 35 millimeter film. And I've gotten to a point where I would have this camera with me in meetings I go to. And being in San Francisco, I meet incredible people, talented people. I just started taking pictures. And that hobby got very popular to a point people would take meetings with me to get pictures. And one of my mentors recommended I sell these pictures because they wanted to put them in the house. I never charge for a photo, but I will sell the photo if people want to buy it. Mm-hmm. So at one point, I was paying half my rent just selling pictures online. So that talent, like an entrepreneur, like your side hobby becomes your full-time. And I got invited by crazy people to take their pictures. Some of them had to deny because of ramifications. This is a funny story, but one of the potential opportunities for me to take pictures was for Alexander Lukashenko, who happens to be the last remaining dictator of Europe, right? So he's a dictator of Belarus. Mm-hmm. I got invited to take pictures of him for his birthday for Rolling Stones because Alexander Lukashenko was trying to be Belarus was trying to be a crypto-friendly nation, and they wanted a expose in Rolling Stones to project this man as this crypto-friendly VC-style photos because I was taking quite a lot of pictures of entrepreneurs and investors in San Francisco. So they thought I was this guy that was taking this picture. So funny enough, I had to reject that opportunity for obvious reasons. But yes, my photography is a hobby that got very serious, and 95% of the time, my photographs become someone's profile pictures or gets in press and a whole lot of things, right? So I enjoy the process and enjoy the delight that I bring out of people through these incredible pictures and capturing history, right? I have so much history for Cosmos. Conferences happen to be these amazing places where people come and show their essence. Like when people are passionate about something, the way they talk about it, they're very deeply passionate about it, just brings out a look that is very hard to capture in a studio, right? So I love taking people's photos in their essence, in their actions. So one of the photos I took of Sunny when he was coding on Osmosis at a conference in a bar, that tells a lot about that time and that place. And that is something that we cherish over time, right? So photographs are incredible tools to freeze history. And I think that's something I can give back to people.
But people never know that you're taking photographs of them, right? You're like doing it.
Sometimes they do, sometimes they don't. I like candid photographs because people, when they get aware that there's a photographer taking, they change. So I try to keep it candid. Even in the studio, I work with the subject for a while before I take their pictures. My job as a photographer is to get the subject to a level of comfort where they don't change when they see a lens. So that's the most difficult part. When I'm on the field, it's different because when you see a big camera in front of you, you tend to get aware. So I try to use different types of cameras like rangefinders where I don't have to be that obvious that I'm taking a picture and things. So I use tools available to me to get the subject to be comfortable as possible. Yes, I try to be candid as possible. And those are the best pictures always.
Then let's go over to your main job. So
full-time job.
Like a couple years ago, I guess, you started Overclock Labs, right? And that transformed into like the main contributor to Akash network, correct?
So 7 years ago, we started Overclock Labs and created Akash. And now Akash is supported by several other entities as well as incredible set of developers all over the world. Yeah.
And how was that born? Or let's start with like, what is Akash actually?
The origin story?
Yeah.
I think the roots of Akash really trace back to 2011, 2012 timeframe, where I founded a company called Angel Hack. And Angel Hack was this company that made hackathons mainstream. So before Angel Hack, hackathons were a very underground concept. Hackathons were done by NASA and institutions like that. But the startup hackathon wasn't very popular. So Angel Hack, we took the idea really to bring people together, bring a bunch of builders together, put them in a single room and make them comfortable and challenge them and see what comes out of it. And it turns out that was very attractive. Angel Hack got extremely popular and we were doing several seasons in a year. And every time we did a hackathon, TechCrunch used to write about it. So you can like Google and whatnot. So you'll see quite a lot of rich history. Angel Hack by far was one of the most important elements in creating the Web 2 revolution. Right? So at peak, we had 150,000 developers spread across 50 cities. And we were doing hackathons in 50 cities. Massive, right? Massive hackathons. We had Facebook. Facebook used to write blogs about Angel Hack every time we did hackathons, right? So it was a thing in 2011 if you're in San Francisco. And a lot of people I meet today started programming because of Angel Hack. Some of the companies like Firebase was launched at Angel Hack, right? So we had incredible, rich history. And one common thread I've noticed working with lots of developers happened to be the difficulty in deploying their workloads, in particularly scaling. So what happens usually is when you start a project at a hackathon, you find people to work with and you complete them, and then you spend months building it. And then all of a sudden you get users, but then you got to scale that, right? So that becomes extremely challenging for developers. And then you end up in this, if you don't figure out how to scale, the chance of you succeeding diminishes quite a lot. So I found passion in that area and I started working quite a lot. And I worked for a few companies like Demandbase and whatnot that scaled infrastructure to 1 billion requests per day. It was a massive operation. So I was doing quite a lot of like hyperscale work. And then the challenge for scalability happened to be reducing faults, right? So in order to really scale, you can reduce faults, but you got to recover really quickly, right? Mm-hmm. So you can write the best software in the world, but the software always is going to fail no matter what. That's the nature of the software. So instead of trying to over-optimize for non-failures, optimizing for recovery happens to be a very incredible way to scale, right? So with an acceptable fault rate. A technology called containers were getting popular. This was before Docker was existent. And Google really proved out that using containers, you can really, really scale. And Google, by far, is the most scalable company in the world in terms of technology, right? So the idea was very fascinating for me. So I started working on this incredible field to make it a reality. So I started working on different schedulers and wrote a few libraries. And then those libraries became were used by Kubernetes and Docker and all these incredible technologies that came out. And I started the company Overclock Labs to take Kubernetes to market. This is before anybody heard of Kubernetes, right? This is in 2015. Today, Kubernetes is used by 80% of the cloud, so just so you know where we're coming from. And there was also a scare that cloud providers were getting increasingly powerful in a way that we as a user are increasingly getting dependent on these cloud providers for every little function, right? For fault tolerance, you depend on cloud providers. The idea was, well, if you can somehow reduce the reliance on the cloud provider for basic functions like fault tolerance and bring them to a higher plane. We have more sovereignty and more control. Mm-hmm. Just like how when you select a database, you want to almost select a SQL format because you can take the SQL and put it in another database and you can run pretty well, right? So the interoperability was getting hurt with cloud providers because each of them were optimizing for you to stick with them, right? So interoperability was a concern, and the idea of a supercloud was just kind of getting popular. Cornell University wrote a paper in 2015 introducing the idea of a supercloud. And we were working on containers, and we brought the containers and Supercloud together. And we discovered that a key missing piece for the Supercloud idea was a marketplace, a way to acquire resources. And that's really the foundation of Akash Network. We did quite a lot of research and work in bringing Supercloud, bringing the marketplace component. And when we decided to do so, we thought doing it in a decentralized and open way really matters because the direction the incumbents were going were extremely closed. And we didn't align with that direction, us being open source developers. And my entire career exists because of open source software, right? So, and if you were to add sustainability to open source software, you need networks. And the only data structure we found where you can have a highly sustainable networks were crypto, right? So crypto gives sustainability to the open source software. And then one thing led to another, and then here we are. Akash Network is the first decentralized supercloud. The idea of a supercloud, a decentralized supercloud we introduced in our white paper in 2018. Now you see if you Google supercloud, you'll see Forbes and see all this mainstream media writing about supercloud. Really, they discovered like last year, but we were pushing the idea of a supercloud for 5 years, right? And we launched that 2 years ago. Mm-hmm. And now when we launched it, we decided, of course, not to wait to build the entire thing, but rather build important features that would get us to next step throughout the journey, right? So step by step, we launched as a very ephemeral cloud, and then we added storage. We added discovery using IP addresses. Now we're adding the GPUs, and next is automation and so on and so forth. So eventually, the goal is to get to a point where we are in parity with the large cloud providers like Amazon's and Google's of the world. So now you can actually comfortably say, like, you can use the supercloud as a good alternative, if not augmentative, to your existing infrastructure. So we're getting there, and we're getting there by focusing on critical components like GPUs and whatnot every step of the way throughout the journey.
So, but you said supercloud, right? Or decentralized supercloud. So what's the definition of a supercloud? Like, how is it different from a normal cloud?
So in a regular cloud, you rent capacity from a provider, right? So cloud provider, and you rent them, right? Mm-hmm. So providers like Amazon, Google, Microsoft, all of them have built this hyperscale operations. You pretty much unlimited supply, right? You can get, for the most part, not for everything, for the most part. And they've started adding other premium services on top of your compute, like databases, like caching services, like load balancers, and a whole lot of other things that you would normally need for a distributed application to function. You can rent them instead of managing them yourself. So the cloud, and now they started offering, most of these offerings were open source projects, really white label and offered as their own service, which questionable tactics, but at least you know that the underlying software is open source, so you can port away in case you wanted to. But slowly they started introducing cloud-only applications like BigQuery, which comes from Google. I mean, it's good, but if you use BigQuery, you're stuck with Google. Or the Amazon's Aurora database. If you're using Aurora, you're stuck with Amazon, right? They started slowly locking you in. So now, if you have to scale out or like optimize your costs, it's impossible. I mean, recently, Andreessen Horowitz wrote a very thorough, thoughtful research piece where they estimated, in fact, backed by data, they pointed out over 50% of the margins that these online services goes to a cloud provider. Like, if you use Dropbox or Asana or Netflix, 50% of the payment or the profits are going to the cloud providers. So there's an invisible tax we pay, like it or not. right? And the reason cloud is so sticky is because of these value-added services. Now, the idea of a supercloud, and that means you can't use multiple providers, because if you use Aurora on Amazon, you're pretty much stuck. You can't use Google, right? So the idea of the supercloud was like, well, if you want to really take advantage of like this underlying resource set, we can essentially create a model where the supply, the providers can be heterogeneous in nature, whereas the interaction, that means the user using the product, will get a homogeneous interface. So it doesn't matter what provider you use underneath, you still get a common interface that you can interact with. So that makes it extremely easy to port across different providers, interoperate across different providers, and really leverage what provider gives you the best option instead of being stuck with one provider, right? So by bringing all the critical functions like fault tolerance and automation and access control and payments and all that good stuff about to one layer, you don't have to rely on a single provider. So that's the idea of a supercloud. And Cornell proposed this. We really like that idea because that's really how you take back the power, right? By giving them less power, but still using these cloud providers for what they're good at, scale and hardware, right? So, and now if you add a way for these providers to sell compute, right? To sell compute in a manner that the user doesn't even care what provider they're providing on. I mean, they care if they want to, but they don't have to care, right? As long as these providers satisfy certain requirements and attributes the user is looking for, you shouldn't care. And as long as these providers and the payments are going to happen invisibly and frictionlessly, the provider shouldn't care. The user shouldn't care. That's what a decentralized provider, a supercloud, brings. And that's what Akash is all about. So taking the idea of a supercloud and expanding that with a marketplace and a component that makes compute utilization a lot more optimized, right? So right now we have, if you look at the landscape, most data centers, there are about 8.4 million data centers in the world. Most data centers are not used to the point they're supposed to be used. 85% of time, they're unused. So if we can leverage the supercloud and connect these data centers and actually get a price point that's significantly lower than what you would otherwise pay to these hyperscalers. And that's what we're seeing with Akash, the incredible price savings, right? And then if you really go expand on the concept of like, well, is it just cheap cloud? It's no longer just cheap cloud. It's about access, right? It's about access to the GPUs. I'm happy to get into it. How GPUs are really incredibly hard to get, but they're also stifling innovation because the cloud providers selectively choose who they give the GPUs to. And that's a big thing for Akash to solve that problem.
But why do you even need a blockchain for that? Did it start with the blockchain stuff in mind, or even launching on Cosmos or a Cosmos chain? I mean, you're one of the first ones, right?
Yes.
Yeah.
Why do we need a blockchain? So before we answer the question, we should really ask, why do we need open source software, right? So there are two ways to do this. We can do a closed approach or we can do an open approach. A closed approach is going to be a company essentially offering this marketplace service and providers signing up. And great, company makes profit, everybody is happy. But there is an inherent limitation. The company needs to raise a lot of money. We're talking about hundreds of millions of dollars to even do anything meaningful like in the space, because you need to hire developers, you need to hire salespeople, you need to hire a complete, like you need to build a large corporation for the company to even succeed. Second, you need to convince the people, the operators themselves, to install a closed source software in their infrastructure. Third, you need to address when you have a centralized company, regardless what the founders intend the company to be, the structure is created in a way that people are only incentivized to increase shareholder value. Not that shareholder values may not align with the user values, right? So I'm not saying, so Amazon's, Google's, Microsoft of the world are incredible companies, and they're going to optimize to increase the shareholder value. And that's the scenario today we face. Amazon today is being investigated by the US government. I don't know if that means anything anymore these days, but Amazon Web Services is being investigated for their anti-competitive practices, right? Because Not because Amazon is bad or anything. It's just the way a centralized closed company is set up is incentives are misaligned. So that's why we need open source software. With closed source software, we can go fast, but with open source software, we can go further. And that's a core difference, right? Open source is very critical. Without open source, we wouldn't have what we have today. Without open source, Google wouldn't exist. Without open source, internet wouldn't exist, right? Imagine every piece of software you interacted was closed source. Imagine having to get a license to use TCP/IP. The world would be in a very different place. That's why we need permissionless, open, transparent systems, right? Now, how do you build a permissionless, open, transparent system? Like, let's look at all the available options today. We can be a closed company can create a open source to source code. And there are two main models the company will survive. One model is to sell services, right? Only Red Hat was the only company that was able to pull that off. No other company did that. And second, or like support essentially. Second model is to do open core, where you open source the core, but everything beyond that is closed source. The problem again is misaligned incentives. There's no incentive for the company to support the open source software. And the open source software is always going to be degraded experience in the closed source software. That's just the way it is, right? Because you're going to inherently give bad user experience to the open source software so you can have good experience in the closed source software. Misaligned incentives again. So that's not going to work out. So how about a third model, which is tokenized open source software? Open source software with a token adds sustainability, gives permissionless, so it aligns incentives, aligns and attracts developers, right, to build the software. So it was very critical for us to keep the software open, keep the software pure. The only data structure, only corporate structure or economic structure that allow us to do that is through crypto.
Okay.
Now, why an app chain? Why can't we do it on Ethereum? Why our own layer? We actually tried doing on Ethereum in 2017. Our first prototype was on Ethereum. And in 2018, CryptoKitties launched and it crashed our application. So Ethereum in no way is meaningfully scalable, right? Just now we are seeing some amount of scalability, murky, but we're talking about 2017, 2018 timeframe. Ethereum wasn't ready. And then we looked at, well, how do we build our own blockchains? And we found a library called Tendermint. A friend of ours told, I think from a Go user group, somebody told us, because Tendermint happens to be in Golang and I happen to be a Golang developer, all of our team, we're very deep, right? If you look at my history, I've been trending in Go on GitHub Golang categories several times, my libraries, right? So I'm a very pro Golang person. We found this beautiful library called Tendermint that would give consensus, that allow us to build our layer one blockchains. And we got in touch with the team, Jaquan and others, and they seem to be pretty decent people. I did see quite a lot of development in this repo. That's why open source is very important, because that tells me as a developer a lot about an application without even talking to anybody from this. I don't have to talk to a sales guy. I don't have to talk to a founder. I look at the open source development graph. Who's contributing, how much time, who's contributing when and how. Open source tells me, the transparency tells me everything I need to know about a piece of software, and that is very important to me. And we took this open source library, we incorporated it into our idea of a blockchain, and we launched our prototype. And then we ended up building quite a lot of modules. This open source library, Tendermint works on modules, right? You develop staking accounts and all that as modules on top of this consensus engine. A lot of the modules did not exist. We ended up writing a lot of the modules ourselves. And then Cosmos SDK was created with a lot of these modules people developed, and along with the Tendermint engine. And once that was released, I believe in SDK came out in, Cosmos Hub launched in 2018. The SDK came, I think 2019, became like a decent usable SDK. And we switched over when IBC was introduced. We were on Tendermint. We were like kind of not a fork, but we were like off the upstream quite a lot. And then we threw away 70,000 lines of code in 2019, I think, and switched over to Cosmos SDK. So we're the first blockchain to talk to IBC, right? The first IBC transaction happened between Cosmos Hub and Akash Network. So it was some deep sort of like rooted history as to why we need open source and why the token. And token here really secures the blockchain. secures Akash network being a proof of stake network. And without the token, there is no network, right? There's no way to secure the network. So the value of the token needs to grow in proportional to the economic activity that happens on chain, or else the economic activity that happens on chain is at risk of attack, right? So that's the direct correlation between the token and the economy of the cloud.
That's one reason why I was interested from the start, and the reason why I got pulled into Cosmos was Akash, because I needed to find out how to buy Akash. What is it? What's IBC? And so the network needs Akash, the token, but also the network, and everything happens there. But do you think there will be, in the future, will be users that even know that it's running blockchain tech in the background? Is that a goal to somehow hide that?
The goal is to make sure the user doesn't know or doesn't care they're using Akash on the background. I mean, that's the direction we're going anyway, right? So slowly, as we add capabilities, we're enhancing the ability for the clients to abstract away Akash as much as possible. And that's very important. So today we have several clients, and Akash being open source and permissionless, it's very attractive for developers to build applications on top, right? So CloudMouse obviously being a very popular one. We have Fleek that's building incredible client for Akash. We have Speron. We have Praetor. We have several others. Terraform, there's a whole other clients that are building for Akash. And when you're using Speron or even CloudMouse, maybe CloudMouse, quite a lot of you using Akash, but Speron and Fleek, you don't know you're using Akash, right? And we are working with the larger companies as well. I wouldn't want to name any, but actual larger companies that are actually we're integrating with Akash to a point where you're not going to know you're using Akash, right? When you use Uber, you don't really care that you're using internet and packets are going over TCP/IP. You shouldn't. These are protocols, and protocols are always should be hidden away from the user. And I think with AI, with the way we're going, a permissionless and decentralized GPU network is going to be so critical to power this enormous demand that we're getting with AI. And a lot of times you're just interacting with a chatbot, or you're interacting with a device, maybe on the Apple Vision Pro, but you're talking to an AI, and that AI is using Akash in the background, right? So you're not going to know. You shouldn't know. And most people don't know Netflix runs on Amazon Web Services. They shouldn't. They just use Netflix, right? So that's the direction we're going to go. And we're getting there. Now it's very obvious when you use Akash that you're using Akash, but that's not going to be the case for a long time.
And if you explain what Akash is to non-technical people, how do you usually explain that? Because I find it quite hard to explain that.
Good question. I find it very hard to explain that as well to non-technical people, right? So the simplest analogy I give is Akash is like Airbnb for data centers. They're like, okay, what is a data center? So data center is a physical machine that stores your data, my data, or the cloud. So data center runs the cloud. So I think that is the best way to explain to people analogy-wise. It's very hard to explain a programming language to a non-technical person, right? Like how would you go super abstract and be like, hey, Akash is a cloud provider, right? What is a cloud provider? Cloud is where your data and my data is stored. I wouldn't even call it a cloud provider because it's inaccurate. It's really a cloud network. But then do people care? A non-technical person. So that should be a challenge to our community to come up with a definition, because it's hard for me to explain. In all honesty, it's hard for me to empathize with a non-programmer because I do not remember a time in my life that I did not know how to program.
Yeah.
I don't. I started programming at a very young age. In fact, I started programming in third grade. So I think whatever that is, right? But I became professional programmer in seventh grade. I was doing C++, seventh grade. So seventh grade, I was 13, right? So long before that, I was programming. So I don't remember much. My brain works as a programmer, right? So I find it very hard. My girlfriend's not a programmer. And even she doesn't understand most of the time what I do. Right? So
for me, Akash feels a bit like a organism, because it's the network itself is more like growing. At least that's in my head. That's what the visual image I have in my head, that it's more like an organism that connects the resources together, like the people that demand resources and the others that provide them. And usually it's a company. And with Akash, it's just that technical solution, right? It's like it takes away the company in between me and the provider. That's just in my head. So you started with more basic services, right? And now people are able to rent whole servers using Akash. And you're currently rolling out or testing the final stages of GPU support, right? So how does that has an impact on the current AI revolution?
So machine learning or AI, it's called AI, simple definition. Really, it's machines that are learning. And there are lots of ways machine learns, but a popular way is using neural networks. So, and in order for these machines to learn, they need to perform extremely complex mathematical calculations, right? And these calculations need a lot of computational power, a lot of specialized computational power that doesn't usually exist in the central processing units of computers that we have, our CPUs. So they need additional processors called graphical processing units, the GPUs really. And in that, it's certain type of GPUs, right? So they need, what that means is they need specialized chips in addition to your regular CPUs for them to function for training or for using that training, which is called inference, right? So, and these chips are in a very short supply. They were already in short supply, but even more so because the demand for AI has quadrupled, like literally. It's gone so high, but unfortunately, the supply is not catching up, right? And there's only one company that makes these chips, good chips that are useful for AI, and that happens to be NVIDIA. Why that's the case? Because NVIDIA made incredible investments 10 years ago that makes their chips amazing to work with for AI developers. No other company, be it AMD or Intel, have gotten their AI investments or invested into AI software good enough for people to use it, right? So NVIDIA is really a software company. I mean, sure, they have hardware, but it's really a software company that I think understood what developers need and delivered an incredible product, fully vertically integrated product. They're like the Apple of chips, right? They make hardware and software work really well. So since there's only one company that makes them, that obviously becomes a bottleneck. And if you look at the supply chain, how this company makes them, they don't make the chips. They actually have another company called TSMC, or a Taiwanese Semiconductor Manufacturing Corporation, that actually makes the chips. TSMC makes 70% of global chips. They make chips for Apple, makes chips for everybody. And they rely on another company called ASML to create this factory. So there's a whole complex supply chain that's involved in getting these GPUs and getting that functioning AI. So NVIDIA is constrained by their supplier, and their supplier is constrained by their suppliers. It goes on and goes on. During COVID, the supply chain was severely impacted. To a point, it created artificial shortage, a temporary shortage, but that temporary shortage has been fueled with a demand for AI. So for the next 2 to 5 years, we're not going to be able to solve the supply chain problems. And on the other hand, what's happening is, as companies get serious about AI, they tend to buy these chips as much as possible because they need these chips to run. So these chips are the oil, the GPUs are the oil for AI. And so right now, it takes about 2 years to get the advanced chips from NVIDIA. We're talking about H100s, which is the most advanced chip NVIDIA has ever built. And, well, can we go to our existing supply chain, which is cloud providers? Turns out, if you go to a cloud provider, if you're a startup company, you're required to make large deals, sometimes north of millions of dollars in commitments per year to get access to these chips, because these cloud providers are selecting who they give the chips to because they want to satisfy their high-paying customers. They don't want to give these chips away on demand because they know the demand is so high. So you have to have buying power, and a lot of startup companies don't have that. They want chips on demand. So there's this crazy gap for chips. I get inbounded by so many on a weekly basis to get even access to the chips, right? So I get crazy demand for the chips from small to mid-sized companies, even large companies not having access to them. And turns out there are companies that went to Amazons and Googles and Microsoft of the world and made these deals and committed certain amount of money that they'll spend. These companies are unable because they don't have, because they're just signing these contracts to get access to those chips, but they're not using them. Right? Mm-hmm. So it turns out they need a secondary market that can essentially allow them to sell their unused contracts on to people that want to use the chips is very attractive. And it turns out a lot of machine learning companies, because the demand is so high, they're just buying these chips whenever they can. Mm-hmm. Not necessarily using them, just having them, right? So if there's a way for them to lease these chips out without losing the ownership of the chips, it's very attractive, right? So a secondary market is very important now to solve the supply chain problem. And that's what Akash is solving. Akash is the world's first open secondary market for high-advanced, high-density GPUs like A100s and H100s. And that's just a start, right? So once we have the user comes for the chips but stays for everything else because it's open, because it's easy to use, because it's programmable, it's composable, it's permissionless, incredible properties. And the price point is completely transparent, right? So there's no way Akash is going to take unknown amounts from the user. Any amount Akash takes is completely transparent, completely claimable, right? So we do have a take model where the portion of the hosting fees goes to the token holders, right? If a user want to capture some of the take value, they can go stake their Akash tokens and get the take value. So it's open for anybody to get profit and completely transparent. So it's a very attractive model for both developers as well as providers.
And how does the process work for those companies that use Akash or anybody for GPUs, but also for servers? Like what's the process to use that?
So there's so many ways to use Akash, right? There's so many different clients. I mean, like I said, there are 4 different web clients and few non-web clients. So pick a client, CloudMouse, Fleek, Speron, others, and Console. Of course, Console is built by Overclock. And the user essentially defines the needs in a format called SDL, or Stack Definition Language. They basically say how much compute I need and how much I'm willing to pay for this compute. That order goes on chain, becomes a buy order, and providers that can supply to this buy order, that can fulfill this order, bid for the order. Bid by specifying a price, and the tenant looks at the bids and choose the best bid that aligns with their needs. Be it price, obviously is very important, but it's not the only factor. Sometimes the quality, sometimes the reputation of the provider, and a lot of attributes that goes through a user selection criteria, and the user is completely free to choose which provider they want. And it's a very important element of Akash Network, the freedom the developer or the tenant gets, right? Instead of the system choosing what provider they should, right? Mm-hmm. So once they pick a provider, a lease gets created on chain, and a portion of the fees is required to be deposited into an escrow account, which then is distributed to the provider on a frequent basis, right? So as long as there is money in the escrow account, the application runs. If the money dries out, the application stops. And that's how, at a very high level, how the network functions.
And how does the network itself, or Akash, make sure that the value gets delivered? Like maybe I book or like I rent something like a server or GPU's power or compute power, but it doesn't get delivered. How is that verified?
So Akash does not verify. Akash just gives you access, right? Akash is a marketplace. Mm-hmm. It doesn't verify if something is fulfilled or not. Similar to Airbnb, you can't verify if a guest services or not. So that really depends on the guest or the tenant, right? And so we have a reputation system that goes on chain, and there's a decentralized network of auditors that go audit a provider, and they post the results on chain. So it really comes down to whether you trust a provider or not, and your trust is based on different attributes and the transparency the system provides you. Verification is a very expensive problem in compute. You cannot build verifiable general purpose computers. It doesn't exist. And there's some research happening there, but general purpose computation on a verifiable model it defies the rules of physics, right? So it's not possible right now. And the best model we have is reputation. Sure, can there be fraud? Yeah, there could be acceptable level of fraud, like we see with Googles and Amazons of the world, right? But that fraud is quickly like quenched if the service doesn't get delivered. Like, for example, if you're fine-tuning a model, let's say Stable Diffusion on an A100, you know exactly how, the specs are out there. You know the benchmarks that are out there, right? How long it takes. If a provider is unable to fulfill those benchmarks, the reputation of the provider goes down, and that hurts their ability to attract further workloads, right? So the market will self-correct and with an acceptable level of faults for the benefit that we get, which is an open and decentralized marketplace.
So I read some tweet, I think of you, about GPU Stardust that is like collected by, or like that all those single GPUs of people could be theoretically utilized by Akash. Is that the plan? Is that still going to happen?
Anyone with a GPU? Yes, you can. Anyone with a GPU can provide compute to Akash, but chances of your GPU getting selected depends on the application, right? Because Akash is an open marketplace, right? So you have to provide a GPU that's attractive to the user. If not, that GPU will not be used, right? So you don't get paid, essentially. And right now, the type of GPUs that are very attractive from a demand standpoint are high-density NVIDIA GPUs like H100s and A100s, right? Please, if you have an extra A100 lying around, please put that on Akash. I think it's very valuable. So as you come down the stack in terms of density or advancement or whatever you want to call it, you have A6000s, 5000s, 4000s, and you have other data center grade GPUs. As you come down, they become less attractive. Not that there's no demand for them, there's less demand for them, right? Because the high-end GPUs can run applications so much faster than the lower-end GPUs. So the price point had to be attractive for the buyer to go to a lower end. And usually that's rooted in how parallel the workload can get on lower-end GPUs, right? But there's good news, though. What we're noticing is most advanced models like GPT-4 and GPT-3.5, all these advanced models work well on high-end GPUs, but as they mature, as they get older, they get optimized to work on a distributed set of GPUs, like 3090s, 4090s, and whatnot, the lower-end GPUs, right? Like gaming machines. So people that prefer these mature models over advanced models can use the lower-end GPUs, and those companies that depend on a mature model tend to be companies that are looking to build a moat. So what that means is, if you are a startup company and just starting out and you want to experiment and iterate, use a new model. And new models need advanced chips, right? Like the difference is when you're fine-tuning, let's say, Alpaca on a H100, it takes minutes versus doing the same thing on a lower-end processor, it takes hours, right? So if you're a developer, they're like, oh, you want something in minutes instead of hours, right? Because your time is valuable here, right? So that's the math you need to do. But once you figure out what you need, you can use a more mature model to achieve the same results, but pay lower cost, right? So the equation really comes down to the stage of the developer, the stage of the company, the stage of the project, I'm talking machine learning projects, to determine what type of GPUs they use, right? So there's no way to say right now because we don't have the data. Yep. Nobody publishes the data. But I can't really say if your lower end GPU is going to be useful or higher end. I mean, I know for sure higher end GPUs are useful just because of the data that we get. But we got to wait and see how these lower end GPUs are going to come to fruition. But the good thing about Akash is all the data is transparent and available. Like you can actually see what kind of orders are getting placed on the market, what orders are getting fulfilled, what orders are not getting fulfilled. If you look at unfulfilled orders, you'll get an idea as to what kind of GPUs people are asking for so that you can actually supply to the unfulfilled market, right? So that's how the open market dynamics will play out eventually.
And sometimes when I, on Twitter, read about, for example, AI projects, tokens like Render, sometimes also Akash gets mentioned in the same situation or same context. But how is Render different than, or how is Akash different than Render? Because it's the way more popular thing people know, right?
Yeah. So, crypto, there's quite a lot of misinformation and quite a lot of like hype, quite a lot of culture that worships figureheads, people, right? People like SBF was celebrated for a long time, right? We have this like cult-like central figure-based communities. And that's just crypto, right? There's nothing you can do about it. So how does Akash compare to Render? Really is Akash, they're very different products, I would say. Akash is an open, decentralized, permissionless, with an open source code base that is really governed by a community in an open way, right? Every meeting, every product discussion, every roadmap setting, every funding discussion is done in the public for Akash. We look at our GitHub community. It's a very open system. Whereas Render is a closed source software that is hosted on mostly, I believe, Amazon's and Google servers that no one can just participate. It's not permissionless, right? And that you pay using a credit card. You don't need the token to pay for it, anything. So it's a closed source software. I mean, some might consider it as a SaaS software, right? Because you go to a website and you pay using a credit card and you get services. I mean, it's a good way to deliver value too. It's not bad. It's just not open and permissionless. So I don't think comparing Akash and Render in the same sentence is a good way to compare. It's oranges and apple, right? Akash is open, Render is closed. That's just the nature of it. So, but for some reason, they tend to advertise themselves as a decentralized and open protocol. I mean, like that, I think I have some concerns with. And I called them out on it, and they blocked me from their Telegram. So I'm very open about, I think it's very important us as industry to protect, to self-regulate, like to self-regulate bad actors, to weed them out, to expose them. I very strongly believe that crypto should be open source. Crypto should be transparent. Closed systems got us into the trouble that we were in last year. If you look at FTX's, Celsius's, name one massive failures, all these were closed systems, right? Or heavily centralized systems. So decentralization is very important, especially now with state level attacks happening on this ecosystem. So building decentralized systems means building resilient systems, right? One attack on Render, one state attack on Render will, if OTA, the company behind Render, disappears, the Render network disappears right now, right? If Akash, the company behind Akash, which is Overclock Labs, disappears, Akash will run, right? Overclock Labs operates one provider out of 50 other providers. We operate one provider for testing and updates, but if the provider is gone, there are 49 other providers that pick up the load. We don't run any validators for Akash, right? So it's very important. Like even development is completely open. So if we disappear, the company disappears, the development will continue, right? You don't have to work for Overclock Labs to build on Akash. It can be anybody, right? So I think those are very important aspects of Akash versus Render. And Render was doing rendering, but then they offered on their hosted platform, they offered Stable Diffusion, just the inference. And so their community just celebrates Stable Diffusion and Akash and Render entering the AI era. But in reality, Render can run one model. Akash can run about 15,000 models on Hugging Face. Any model on Hugging Face, you can run on Akash. Render is optimized for Stable Diffusion only. As far as I know now, we don't know the roadmap because they're not very open about it. I asked them. They don't want to share the roadmap. So we don't know much. It's a very closed company.
So for people that have resources, like they have like servers that are currently not in use or like, just basically the computing power they could sell on Akash, where would they start to look at? Like how would they figure out if Akash even works for them?
Go to docs.akash.network. If you go to providers, there's extensive documentation as to how to get started as a provider. You don't have to talk to anybody. You can, as long as you have a Kubernetes cluster running in your servers, installing Akash is a breeze. It's very simple. Or you can use an application called Praetor. PraetorApp.com, I believe, is the website. Google Praetor Akash you'll get. Praetor gives you a beautiful user interface that you can install Akash agent in your data center, including Kubernetes, with ease than using command line. So there are two ways to become a provider right now. And there are going to be a lot more ways very soon. In fact, we are working with, I can't really disclose. We have new integrations that we were working with, which makes provider membership a lot simpler as well, right? If you have existing relationship with this large company. So anyway, it's getting better and better as well as we speak.
And what applications are built on top of Akash right now? So you mentioned Praetor, right? CloudMorse.
Yeah. So we have 400 applications, I believe, running on Akash right now. So I would say two category of applications, right? One is the protocol clients, we call them. So these clients are doing something and using Akash to enable deployments for their users. Mm-hmm. Each of them have different flavors. Overclock built console to focus more on nodes. Then we have, I believe, Pocket Network as well as building on Akash now for hosting their nodes in a decentralized way. They started the integration. Then we have CloudMOS, which is the first non-custodial client for Akash. Then we have Fleek, which is beautiful, which is like a Web3 Vercel. They're using Web3 as a backend and delivering an incredible experience. That's obviously very custodial. You pay using credit card. Speron, I believe, is a hybrid between non-custodial and custodial. They have a non-custodial option as well as a custodial option. And they're taking Akash to Polygon ecosystem, whatnot, right? So, and then we have Praetor, which is the provider client for the providers, Akash protocol client for providers. Mm-hmm. And lots of other applications. If you go to ecosystem.akash network, you'll see a list. I don't think it's fully up to date yet, but we have research that's deployed on Akash. We have Osmosis and running their front ends on Akash. We have Mars Protocol. We have, I believe, DYDX is going to put there, according to Antonio from DYDX. I believe they're exploring hosting on Akash, the front ends. And lots of decentralized applications prefer Akash because of its alignment in terms of how the product is built. And we also have, I'm really excited about the machine learning. I mean, there's so much demand there. We recently introduced our testnet. We're starting the incentivized testnet in a week or so. We have about 300 signups right now for the incentivized testnets. So a lot of them are doing machine learning. So about 150 new applications, machine learning applications are going to be on Akash very soon. So as we launch our mainnet, I think we're going to see an explosion in machine learning because the value prop is very clear and demand is very clear.
And there's also Akash AI, right? How is that different from the Akash network?
That's a secret project of mine. Akash AI is essentially, when we said, because Akash is a general purpose platform, that means you can do anything on Akash. It makes it hard for anything on Akash because you can do everything on Akash. Mm-hmm. What that means is, in order for you to deploy a certain type of application, the platform has to be customized to work for that type of application in order to have a good user experience. That's just the trade-off, right? You can build a system from a user experience that's easy to use and very capable, right? A very important design choice we made while building Akash was the foundation has to be capable and not necessarily easy to use. Because making that trade-off very early in the system makes the system less capable and by then makes it less usable, right? So if we make the system very capable, clients can build the usability on top of Akash. The clients will make it easy to use Akash, right? And customize the experience to whatever industry they can focus on. So just like how Fleek is focusing on Web3, Speron is focusing on Polygon and other ecosystems, Overclock Labs is building a verticalized version of Akash or a client on Akash to focus on machine learning, right? Machine learning users don't necessarily care about crypto. They don't want to use crypto tokens. They don't care about crypto. They want to run a model using Python or JavaScript. Mm-hmm. That's what they want. Akash obviously is not going to make those concessions. Akash will not going to have a credit card because it cannot, right? Protocol that doesn't work that way. So there needs to be some bridge between an AI developer and the Akash network. And that's what Akash AI is. Akash AI is a verticalized product from Overclock Labs that focuses on machine learning users.
And how does it make the lives of developers better, like Akash AI specifically?
The goal is within 2 lines, you should be able to run a model instead of doing 14 different steps to use Akash, right? So you open your Python, be like model.get, stable diffusion, .run, prompt, and boom, done. Mm-hmm. Model.fine-tune, stable diffusion, set your data, done. 2 lines, 3 lines. So as a developer, you don't care where it's running, how it's running. You get really good access to high-end GPUs, and it's all that is handled. All the blockchain interaction, all placing the order, selection the order, all that is like completely handled for you. Really customized to run your type of application. So we know Stable Diffusion runs in a certain way, right? It's optimal to have certain topologies, and we're going to handle that for you, right? So it's the first time. It's going to be so amazing for AI. I mean, of course, it's for AI devs. I mean, Akash AI has AI in the thing. You won't be able to run a website or a platform for websites. Use Fleek or use Akash directly, right? So it's a very heavily customized environment for AI development.
People that bought the Akash token a couple of years ago, like, I don't know, in 2021, they might be seeing the price action in recent years and think like, Akash really didn't take off. So what do you think? Why do you think Akash didn't take off till now? Like, why is it still under the radar?
I would not comment on price, and price is one of those things that turns out doesn't really have that much relation to the product you built. So why it didn't take off? Because it's a broad question, but my thoughts are like, it lacks the appeal of the narrative so far. It didn't fit into the narratives. And during the last bull run, narratives were DeFi and NFTs. Akash didn't do anything in that area, right? We were not a DeFi project. We don't have smart contracts. We don't have any of the narrative building elements of it. And that's a good thing and a bad thing, because good thing is we didn't take shortcuts and be like, whatever was fancy, we didn't change that after the fancy bird. We stuck to our values and stuck to our thesis. Akash is exactly what it is in the white paper we wrote. A lot of projects that launched the white papers ended up building completely different from what they launched, just because something was flashy and shiny. But we stuck to our core and we kept building. And now you're seeing some action, price action, right? Now Akash is top 200, 250, depends on the day, right? Because narratives are like coming aligned, right? Narratives are like AI is going to take off. Like, yeah, we knew that 5 years ago, right? And that's why we stuck. And we're still very early, right? So we're stuck on the fact that Supercloud, yeah, we know Supercloud is going to be a thing. That's why we wrote the paper 5 years ago, right? So we're very early, some might say, for the market to still catch up and understand the value of it, right? Now we're starting to see some relief, some sort of attention, right? But we're still so early, right? So why it didn't take off is, well, we were not narrative chasers. We didn't chase the narrative. And second, the access to liquidity was constrained. I think this generally across Cosmos ecosystem, right? Because we're not an ERC20 network, Ethereum being the first sort of like network to have dApps and launch, was able to attract a lot of liquidity from other integrations that supported ERC20 tokens, be it centralized exchanges, right? So Cosmos didn't have that privilege of support from a lot of exchanges. So that resulted in lack of liquidity. So when you combine a lack of narratives and lack of liquidity, you're going to have a huge impact on price. That's exactly what happened, right? So, but that didn't phase us. I mean, that didn't really matter, because we take a very long-term view of where Akash is. We're here. We don't plan to sell our tokens for a very long time, right? Like, I still have all my original allocation that was given to me from my developer allocation when I began the project. And that's going to remain that way for a very long time. So it really doesn't matter what the price action is in the short term, because if you think about where AI is going, the spend in next 5 years is expected to be $1.5 trillion. A trillion with a T, right? That's 1 trillion is 1,000 billion. And Akash's market cap was what, 200 million? Right? So if you look at room for growth, there is quite a lot. And again, none of this is financial advice. I'm just giving you the reality of the situation, right? So if you look for if you take a long-term view, if you're someone in the market with a deep value set that's aligned to open systems and permissionless systems, the long-term view, it makes it attractive, right? So yeah, so I hope that was helpful in understanding why and where we are. And I spent 7 years of my life on this and ready for next 7 years. So
awesome.
let's ask the same question 7 years later.